Think of a giant city. If every street, every house, and every building shared one huge postal code, chaos would break out. Deliveries would get lost, services would collide, and traffic would be unmanageable. That's why cities are divided into districts, neighborhoods, and blocks. In networking, that same concept is called subnetting, dividing one big network into smaller, organized pieces. Hi guys, I'm DHT Ghost, and welcome back to the DHT Ethical Hacking Mega Course. Episode number 9, Subnetting Concepts, Dividing Networks Like Cities. Today, we'll take subnetting from scary math to real-world logic with examples that stick. For why subnetting exists originally. IPv4 networks were assigned in big chunks, class A, B, and C, but that wasted addresses. Imagine giving a small shop the entire district's postal code. Overkill. Subnetting was born to divide networks efficiently, reduce waste, improve performance, and add security. Subnetting lets you break a large network into smaller, manageable subnetworks, control traffic flow by keeping local traffic local, assign different subnets to different departments, floors, or campuses, strengthen security by isolating sensitive areas. For Tramer, the core idea. Every IPv4 address has two parts: network ID, like the city name. Host ID is higher, like the house number. Subnetting adjusts the boundary between these parts using a subnet mask. The mask decides which bits are network, which bits are host. Example, 192.168.1.10 with mask 255.255.255. Network 192.168.1, host 10. That means this host lives in the 192.168.1 raw 24 subnet. Or real example, dividing a company. Imagine a company has 192.168.0 and 124, 256 total addresses. They want 4 departments, each with its own subnet. Original block 192.168.0. 192.168.0.255, divide into 4 subnets, 26 masks, 255, 255, 255, 192. Each subnet, 64 addresses, 62 usable hosts. Now, HR 192.168.0.026, IT 192.168.0.6426, Finance 192.168.1.28.26, Sales 192.168.1.192.26. Traffic stays organized. Broadcasts in HR don't flood finance. Security rules apply per subnet. Just like city zones, each department has its own neighborhood. George Barnsider notation, the shortcut. Instead of writing 255, 192s, we say 26, 24, 255.255.255, 256 addresses, 25, 255.255, 255, 128, 128 addresses, 26, odd 255, 255, 255, 192, 64 addresses. Every step increases the network bits, decreases host space. For why it matters, subnetting isn't just math. It's control, and efficiency. No wasted addresses. Performance. Broadcast storms are contained. Your sensitive servers isolated from guest Wi-Fi. Scalability. Networks can grow in clean blocks. Without subnetting, imagine putting 10,000 devices in one giant flat network. It'd be like giving a megacity one single postal code. Chaos. Attacker's view. Hackers love poorly subnetted networks. Why? One big subnet, one huge attack surface. Broadcast domains make sniffing easier. Flat networks allow easy lateral movement. A good subnet design forces attackers to work harder, jump boundaries, and trigger alarms. Third parser. Try it yourself on your own machine. Windows, ipconfig, Linux, Bakie. macOS, ifconfig or ipadder. Check your IP and subnet mask. Convert it to CIDR. Ask how many usable hosts are in my subnet. Once you calculate a few, the logic clicks. Fordusactor the big picture. Subnetting is the art of turning a sprawling city into well-planned districts. It makes networks efficient, secure, and scalable. For defenders, it's a tool for control. For attackers, it's a map of boundaries to break. Master it and you're not just crunching numbers, you're designing the flow of an entire digital city. This was episode number 9 of the Mega Course. I'm DHT Ghost, and if this lesson demystified subnetting for you, hit like, subscribe, and share. In the next episode, we'll tackle OSI versus TCP/IP models, the maps of networking. Bye. Until then, keep it ethical, keep it sharp.